truth is in the data.
In the vast, silent theater of the cosmos, there are whispers, echoes, and ancient light.
But in 2007, we detected a scream. A single, brilliant shout of radio energy, lasting only a few milliseconds.
That blazed with the power of 100 million suns.
Then, silence.
We had a name for these phantoms: fast radio bursts.
And we had a suspect profile: cataclysm. A dying star. A cosmic collision. A one-time event.
But what if the ghost returns?
What if the victim cries out from the grave, not once, but over and over? This is the story of a signal that breaks all the rules, a message from the void that repeats.
Now, let's open the case file and begin our investigation into this cosmic anomaly.
To understand the gravity of this case, we must first understand the scene of the crime. The universe is saturated with radiation, the background hum of existence.
But a fast radio burst, or FRB, is nothing like this ambient noise.
It is a spike of coherent radio waves, a blast so energetic that in 1,000th of a second, it can release as much energy as our sun does in an entire day.
When the first one, the Lorimer burst, was retroactively discovered in data from 2001.
The astronomical community was stunned.
The prevailing theory was that we were witnessing the death cries of massive objects.
It's a supernova, or perhaps the merger of two neutron stars.
These are terminal events. The source is obliterated in the process.
For years, every new FRB we found fit this profile.
A solitary burst from a distal point, never to be heard from again.
It was a perfect, if terrifying, explanation.
Then came the signal that changed everything.
The case file is designated FRB 1211002.
On November 2, 2012, astronomers at the Arecibo Observatory in Puerto Rico captured a burst that matched the profile.
It was powerful, it was brief, and it was distant. But then, the impossible happened.
The signal returned.
From the exact same coordinates in the sky, another burst arrived.
And then another. And then another.
This wasn't a death cry. This was a voice.
first investigative task was to confirm the signal's origin.
Was it a local disturbance? Perhaps a malfunctioning? Or something?
The key piece of forensic evidence here is what we call the dispersion measure.
As the radio waves travel across the void, they pass through the thin plasma of interstellar and intergalactic space.
This medium acts like a cosmic prism. It slows the lower frequency waves down more than the higher frequency ones.
So, when the signal reaches our telescopes, it's slightly smeared out.
With the high-frequency pings arriving fractions of a second before the low-frequency ones.
By measuring this tiny delay, this dispersion, we can calculate the total amount of material the signal has traversed. The dispersion measure for FRB 12-11102 was enormous.
It told a clear story. This signal had traveled through an immense quantity of space.
Far beyond the confines of our own Milky Way.
Our forensic analysis placed its origin point in a dwarf galaxy nearly 3 billion light-years from Earth.
The evidence was undeniable.
This was an extragalactic phenomenon of immense power.
And it was repeating.
Herein lies the central paradox, the question that opened this entire investigation. What kind of engine can survive its own cataclysmic detonation, not just once, but repeatedly, to send these impossible messages across billions of light years?
The initial suspect profile was shattered. We were dealing with something entirely new.
The discovery of FRB 12-12-11102 was a tectonic shift in our investigation. It proved that the source of these cosmic shouts could survive.
But its behavior was erratic, unpredictable.
It was a suspect with no discernible pattern, lashing out in furious, random bursts.
Followed by long periods of silence.
While it opened the case, it offered few clues about the underlying motive or mechanism.
For that, we needed a different kind of signal. We needed a perpetrator that operated on a schedule. In 2018, we found it.
The new person of interest is designated FRB 180916.B.
Unlike traditional dish telescopes that must be pointed, KIME is a fixed array of half-pipes
That surveys a vast swath of the sky every single day.
It is the perfect wide net surveillance tool for catching fleeting signals like FRBs.
And it caught a repeater.
This one, located in a spiral galaxy about 500 million light-years away.
Much closer than our first subject was also a survivor.
But as the data accumulated over months, a shocking and profound clue emerged from the noise.
This signal had a heartbeat.
The forensic analysis of the arrival times revealed a pattern of breathtaking precision.
The source would become active, emitting a series of bursts over a period of roughly 4 days. Then, it would fall completely silent for the next 12 days.
After that, the cycle would repeat.
"4 days on, 12 days off."
Over and over, like cosmic clockwork.
The total period of this cycle is 16.35 days. This was the breakthrough that elevated the case from a cosmic mystery to a targeted investigation into a specific mechanism.
Random chance was no longer a viable explanation.
We were now looking for the machinery, the celestial mechanics.
That could impose such a strict, unwavering timetable on one of the most energetic events in the universe.
Our first and most obvious suspect was simple rotation.
We know of objects that pulse with incredible regularity. Pulsars.
These are a type of neutron star, the ultra-dense remnant of a massive star's explosion.
With a powerful magnetic field that beams radiation from its poles.
As the star spins, these beams sweep across space like a lighthouse. If the beam sweeps past Earth, we see a pulse.
Could an FRB source simply be a hyper-energetic version of this?
Let's put this suspect on the stand.
For this theory to work, the object would need to be rotating once every 16.35 days.
This is where the story falls apart.
Neutron stars are born from the collapse of massive, spinning stars.
Due to the conservation of angular momentum, the same principle that causes a figure skater to spin faster.
When they pull their arms in, these objects are born spinning at incredible speeds.
A typical pulsar rotates several times a second.
The fastest ones spin hundreds of times a second.
Finding a young, energetically active neutron star rotating only once every 16 days is physically untenable.
Such a slow rotation rate is characteristic of a dead or dying object. One that has long since lost the rotational energy needed to power these magnificent bursts.
The alibi is solid.
Alone, rotating neutron stars simply cannot be our culprit.
The physics do not match the evidence.
So, we move to our next line of inquiry. G.
What if the periodicity isn't tied to the source itself, but to its environment? Perhaps the object is always bursting, but something is periodically blocking our line of sight. This moves our investigation from a single suspect to a conspiracy, a system of interacting objects. Before we explore that, however, we must address the most speculative hypothesis. The one that lingers in the back of every investigator's mind when faced with a patterned, repeating signal from the stars.
Could it be artificial?
A repeating signal with a clear, intelligent pattern is the very definition of what SETI,
the search for extraterrestrial intelligence, has been looking for.
The 16-day cycle is not a simple pulse. It is a complex window of activity.
It feels deliberate.
However, as scientific investigators, we are bound by a critical principle.
We must exhaust all possible natural explanations before we consider an extraordinary one, like an artificial source.
To date, every great cosmic mystery, from pulsars, initially labeled LGS,
has ultimately been explained by new and unexpected, but entirely natural, physics.
While we keep the file open on this possibility, it is our duty to first hunt for a natural culprit that fits the evidence.
The burden of proof for an artificial intelligence is immense, and we are nowhere near meeting it. We find ourselves at a critical juncture. We have a signal of immense power. We have confirmation that its source survives.
And now, we have a precise, repeating cycle of activity that rules out the simplest explanation.
the easy answers have been eliminated.
The clockwork nature of FRB 8180916.b tells us we are not looking at a lone actor.
Some external force, some larger mechanism, must be dictating this schedule.
We are forced to consider more complex scenarios, companions, orbits, and celestial dances
that could modulate the signal of this powerful, enigmatic object. The case has grown far more complex and far more compelling.
With the simple explanations ruled out, our investigation now requires us to build a profile of a more complex perpetrator.
The evidence points to a specific class of object for the engine of the burst itself, a magnetar.
Magnetars are a rare and extreme form of neutron star, possessing magnetic fields of almost unimaginable power, 1,000 trillion times stronger than Earth's.
These fields can twist and snap in violent reconnections, releasing the colossal energy we observe as a fast radio burst.
A magnetar provides a plausible physical mechanism for a source to survive and repeat.
But this only identifies the weapon. It does not explain the timetable.
To do that, we must analyze the two leading hypotheses for its method of operation. Our first model places the magnetar in a binary system. It is not a lone actor, but is locked in an orbit with a companion object, likely a massive, luminous star.
Such stars constantly shed material in a dense, powerful stellar wind.
In this scenario, the magnetar may be bursting frequently, perhaps even constantly, but its signal is blocked.
For most of its 16-day orbit, the magnetar is shrouded by the wind of its companion.
Its cries are smothered before they can begin their journey to us. However, there would be a brief window in the orbit when the magnetar emerges from behind this screen. When its orientation relative to its companion and our line of sight is just right.
For about 4 days, the path is clear. The beam escapes, and we register the bursts.
Then, as its orbit continues, it plunges back into the obscuring stellar wind.
And the source goes silent for another 12 days.
This orbital model is compelling because it uses well-understood astrophysics
and elegantly explains the sharp on-or-off nature of the activity window.
Our second model suggests the magnetar acts alone, but is unstable.
It proposes that the neutron star itself is wobbling, a phenomenon known as precession.
Think of a spinning top just before it falls over. Its axis of rotation slowly traces a cone shape.
If our magnetar is precessing with a period of 16.35 days,
its beamed emission would not point in a fixed direction.
Instead, the beam would sweep across the sky in a slow, circular pattern.
We would only detect the FRBs during the portion of the wobble when the beam happens to sweep across Earth.
the 4-day active window corresponds to this alignment.
Once the beam wobbles away from our line of sight, the source appears to switch off, only to return when the cycle brings the beam back around. This model is also attractive, as precession is a known behavior in pulsars.
It requires no companion, relying solely on the physics of the neutron star itself.
So we have two prime suspects for the mechanism: a magnetar in an orbital dance, or a lone, wobbling magnetar.
How do we weigh the evidence?
Both theories fit the primary clue of periodicity.
However, detailed analysis of the signals can provide further hints. Some data suggests changes in the signal's polarization, the orientation of the light waves,
which could be caused by passing through the turbulent magnetic environment of a stellar wind, slightly favoring the binary model.
Conversely, other repeating FRBs have been found that lack the strict periodicity of this one, suggesting that perhaps not all repeaters operate the same way. The investigation is ongoing, with telescopes around the world gathering more data, looking for the crucial piece of evidence that will confirm one model over the other.
The final verdict, for now, is this.
The culprit behind these scheduled bursts is almost certainly a magnetar.
The clockwork timing is most likely imposed upon it by an external factor. Either the gravitational pull and stellar wind of an orbital companion, or the internal dynamics of a precessional wobble. We have moved from a complete unknown to a detailed profile of the suspect and its two most likely methods.
The mystery is not yet solved, but the case is no longer cold.
We are closing in.
The investigation on Oumuamua remains active. While we have
The
drawn
investigation
our
on
conclusions based on
Oumuamua
public
remains
data,
active.
yet the complete story is still unfolding.
If you want to access the classified case notes for this investigation, including my full list of sources and supplementary data, consider joining our unit over on Patreon.
There, we continue the discussion. So that can be improved. So we're at most right one.
For now, this case file is closed.